All right, in this video, we are given the graphs of two piecewise functions, and we're supposed to write the equation for the piecewise functions. Now, of course, number 7 is actually an absolute value function, but we'll worry about that later. An absolute value function is just a special case of a piecewise function. So, as we look at this absolute value function, this piecewise function, I'm going to do it in two separate colors. All right, I'm going to look at this part of the graph as the blue side, and I'm going to look at this part of the graph as the red side. All right, that'll just help us keep track of what we're doing. So when we make a piecewise function, we're going to need an equation for the blue side and an equation for the red side. So I see that they're both straight lines passing through here. So in my mind, I'm thinking about y equals mx plus b, all right, the slope form of a line. So I need the slope and the y-intercept. So for the blue side, let's see, what's the slope? All right, as I pick out a couple of points where I see that it hits right on the grid lines, from left to right, I'm doing rise over run, so that's up 3, right 1. So that's 3 over 1, which is just 3. So I'm doing y equals mx plus b, so that's 3x. Now I need the y-intercept, I need the b. Normally I would extend this line and try to see where it touches the y-axis, but just eyeballing it, I can see that it's going to go off the graph before it gets to the y-axis. So that doesn't worry me. Just off to the side, I will use my model y equals mx plus b to find the b value. Now, for the x and y, I will just use the vertex. All right, I'm noticing that the vertex of this graph is the point -4, 6. All right, so that's an x value and a y value. So I'm going to substitute those into my equation as well. So for y, I'm going to put the 6. And then for the m, the slope, I already know that that's 3. And for the x, I'm going to put the -4. And then plus b. So that 6 is equal to -12 plus b. And then I'm going to wind up adding 12 to both sides. So that's going to give me b is equal to 18. So that makes this 3x plus 18. So that means if I extended this line, it would hit off the graph at 18, all right, which makes sense. All right, I might have to pause this video because my students are going to come in and it's going to get real loud. But I'll keep recording for another minute. For the right-hand side, again, I need the slope and the y-intercept. Well, this is going down 3, right 1, down 3, right 1, as I go from left to right. So that's -3 over 1. So I'm just going to have -3x. Now the y-intercept, I can see that this crosses the y-axis at -6. So that's -3x minus 6. Okay, so when I go to make my piecewise function, I can just go f of x equals, and I'll make sort of this brace. All right, the first piece is the 3x plus 18. The second piece is -3x minus 6. So I need the domain restrictions that keep this from being a line that goes on forever. Notice this is the axis of symmetry right here. And that is the line x equals -4. So I need it to be if All right, and this is to the left of negative 4, so that's going to be less than negative 4. This red part is to the right of negative 4, so I'm going to say if x is greater than negative 4. One of these needs to be or equal to keep it from being an open circle. Doesn't matter which one you pick, so I'll just pick the top one. The domain of this graph, it goes left forever and right forever, so that's negative infinity to positive infinity. The range, the y values from bottom to top, it goes down forever up to a height of 6. So that's negative infinity to 6 bracket. Now, let's take a look at number 8, where we will write a piecewise function for this. Let's see, I'm going to change the colors. So, I'm going to need an equation for the blue piece, and I'm going to need an equation for the red piece. So let's see, maybe I can squeeze this in this time. Alright, I'm going to get my little function going and do it right from the start. So the blue piece. I'm still thinking about a y equals mx plus b, like I did on the last problem. So I need the slope and I need the y-intercept. So the slope, let's see. The graph seems to hit right at the grid lines like this. So going from left to right, rise over run. That's down 1, right 2. Notice I said down 1, so that's negative 1 over 2. Also, from left to right, you see that this is sloping downhill, so you know it's going to be a negative slope. So that's negative 1/2 x. Now I need the y-intercept. Well, that's going to be real easy because the y-intercept is 6. So negative 1/2 x plus 6. Okay. If the x values are less than or equal to 4. Now, where did I get that from? I had the equation of the entire line, the one that goes forever. But I'm noticing that this line starts here at an x value of 4. That's where the 4 came from. But it starts here and goes to the left. So these x values are less than or equal to 4. It's a closed circle, so I said or equal to. Now let's do the red side. So again, y equals mx plus b. The slope. This seems to hit point after point. So this is going up 1, right 1. So that's a slope of 1. So I'm just going to put x. Now for the y-intercept, I need to extend this and see where the line would cross the y-axis. So if I were to extend this, it would be like this. And kabam! This would be the y-intercept right here at negative 6. So that would be x minus 6. If x is greater than 4. All right, again, this piece begins at 4. That's why I put 4. It begins at an x value of 4. And it goes to the right. That's why I put greater than 4. And it's an open circle, so I didn't say or equal to. The domain, it goes left and right forever. So that's negative infinity to positive infinity. The range, that's the y values from bottom to top. So the bottom of this graph is down here at negative 2. All right, but it doesn't include negative 2 itself. So I'm going to make sure to make this round to show that negative 2 is not actually included. Just so you go right up to negative 2, but without including negative 2. So anyway, from bottom to top, that's negative 2 to infinity, because it goes up forever. Okay, so that was number 8 that we just did. Okay, what's next? Number 9 refers back to problem number 7 again. So number 9 says, give the following information in graph number 7. So I want the y-intercept. Let's see. So in graph number 7, I want the y-intercept. So looking back at this graph, the y-intercept of the function as a whole is right here. This is where the v touches the y-axis. So that is -6. Well, I should say 0, -6. What about the x-intercepts? All right, these are the two places where this upside down v touches the x-axis. So these are the x-intercepts at -6 and -2. So that means -6, 0, and -2, 0. The axis of symmetry is the vertical line down the middle. So that's x equals -4. Okay, the range and domain we already did. The range was -infinity to 6. And the domain was -infinity to +infinity. Now, here's something new. We need the absolute value equation instead of just the piecewise function. So let's do that real quick. So we know that the parent function of absolute value is like this. Now, compared to that, this vertex, the vertex of the parent function starts off at the origin. But this is left 4 and up 6. So let's see. If I want to do left 4, then I have to do x plus 4. That's actually left 4. Now if I want to go up 6, then I need a plus 6 on the end. Now the number in front here is going to represent the slope of the right-hand side. Notice it's going to be negative, which I knew because this is an upside down v anyway. But this is going down 3, right 1. So that's -3. And there it is. So -3, x plus 4 plus 6. Let's see if I can remember that. So y equals -3, absolute value, x plus 4, and then plus 6. So that'll be my absolute value equation. Okay, now it's time to, we're going to use the graph from number 8 to evaluate at these values of x. Okay, so -4 is an x value. So let's see. So here's the graph for number 8. So we're supposed to go to -4, which is an x value. And so here we are at -4. Now the graph, the y value that goes with this x value is way up here at 8. So that's going to be the answer here. Okay, what about at 4? That was supposed to be an eraser. So here at 4, we are here. Should I be looking above or should I be looking below? I should be looking above. This point down here below is an open circle, so that's not included. So this is the value of the function at 4. And it happens to be 4 as well. All right, the y value is also 4. Okay, what about at 8? Okay, so here we are at an x value of 8. We look up and we see that the value of the function is 2. All right, so that's going to be the answer, is 2. Okay, and finally, let's go ahead and evaluate these two functions given the equation So we'll use these x values and see what happens. So be careful of which function you're using. This is function j, and this is function p. So in problem number 11, it mentions the p. So that means we're talking about this function over here. Now, we're given an x value of 4. We're going to look at the restrictions, the domain restrictions, to decide which one of these three values will be the answer. All right, -4. Is -4 less than -4? No. Is -4 less than or equal to -4, which is less than 1? Yes, because of the or equal to part. -4 is equal to -4, so that's why we're going to use this one, this piece. And normally we would take this and plug it in for x, but this is just a constant, so that just means the answer is 2. Okay, now this one we're using function j. So -3. I'm noticing the -3's here in the domain restriction. So which one am I going to do? Well, the one that says or equal to -3. -3 equals -3, so we'll have to use the top version. All right, that means we're doing the -x minus 4. The easiest thing to do is remember that this means the opposite of x. So -3. So what's the opposite of -3? Well, that would be +3. +3 minus 4 is -1. Okay, this is like -3 is +3, the opposite of 3. I'm sorry, the opposite of -3. Anyway, 0. Still function j, so we're still doing this. Let's see, is 0 less than or equal to -3? No. 0 is actually greater than -3, which means we are going to be using the bottom piece. So that means we're doing 3x plus 2. That's 3 times 0 plus 2. That's 0 plus 2. So that is just 2. All right, so that is how you evaluate a piecewise function if you're given the equation. That's going to do it for this video, my people. I hope it was helpful, and I will see you on the next video.